Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we will discuss about engineering discussion on model paper 1 questions. So we have already studied about engineering typology modules like friction and wear and lubrication. In this session, we will see the model paper questions, which type of questions they have asked and how to attempt for these, how to give answers for these questions. We will see today's session. So the topic is wear and surface treatment. So the model paper 1 questions we will discuss with answers. So the first one is, so they explain the term wear and parameters which govern wear. So first you have to give brief explanation about term wear and then parameters which governs the wear. The wear is the gradual removal or deformation of material at a solid surface due to mechanical action. So already you know we have studied in theory part. So whenever the two surfaces are in relative motion, there is a friction and there is a wear due to the poor surface finish and due to the stress concentration of properties and due to the foreign materials presence on the surface. So various problems are there, various factors are there to removal of or deformation of material from the surface. So it occurs when two surfaces interact, already I told you, and material is lost from one or both surfaces. It may be one surface or both surfaces, material will be lost. So this is leading to a change in shape or surface properties or functionality. Wear can affect the performance, efficiency and lifespan of the mechanical components. So it will affect the performance of the product and it will affect the efficiency and at the same time lifespan of the mechanical components will be reduced. So what are the parameters governing wear? So one is material properties. So hardness and toughness. So harder materials generally resist wear better. The hardness of the interacting surfaces influences the rate of wear. So generally the material properties are hardness and toughness. These are comes under mechanical properties. So harder materials generally resist the wear better. So that's why whenever they interacting the surfaces, the hardness is influence the rate of wear. Similarly, toughness. The tough materials can absorb energy and resist a fracture, reducing wear, particularly in impact or abrasive conditions. So next property is ductility. So ductility materials, ductile materials can undergo plastic deformation. Already you know about this ductility property. This one also mechanical property. So the materials can undergo plastic deformation, which can influence the type of rate of wear. So the ductility, due to the ductility property, yield stress will be developed in the material. So it leads to cause the plastic deformation. So it influences the type and rate of wear. So similarly, microstructure. So the internal structure of a material, including grain size and phase distribution, can impact its wear resistance. So microstructure, the internal structure of a material also it influence the rate of wear. So including grain size and phase distribution. So next one is surface properties. So roughness. Surface roughness affects the real contact area between surfaces, influence the adhesive and abrasive wear. The coatings, surface coatings are treatments, example nitriding, carburizing. So can enhance wear resistance by providing a harder or more lubricious surface layer. So that is the surface coating treatments methods are, one is nitriding method, another one is carburizing. carburizing. So these all the coating methods treatments are enhance the wear resistance by providing a harder or a more lubricious surface layer. Next, oxide layers, natural or artificial oxide layers can provide a protective barrier against wear. So, especially in high temperature environments, it will be happen. This type of oxide layers protection. Next one is load. Again, this load classified in normal load and impact load. So already you know the normal load, the force pressing the two surfaces together affects the real contact area, and the stress at as per it is influence the wear mechanism. So the impact load is cyclic load. So whenever the component is subjected to repeated loads or cyclic loads or impact loading can lead to fatigue wear and surface swelling. So this failure is called fatigue failure. So due to the fatigue failure, fatigue wear will be occurred. So after certain number of cycles, the component fail due to the yield stress. Next, sliding velocity, speed. The relative velocity between surfaces affects the rate of material transfer and thermal generation, influencing wear rates. The sliding distance, the total distance over which surfaces slide against each other, also impacts the cumulative wear. This is you can observe in the pin on disc experiment. The total distance over which surfaces slide against each other, so also impacts the wear. So next, environment. This environment is lubrication. So the presence and type of lubricant can significantly reduce wear by minimizing direct contact between surfaces and reducing friction. So the presence of the lubricant, whenever the lubrication is present in between two rubbing surfaces, so what will happen? You can minimize the direct contact between the surfaces. It means to you can avoid the metal to metal contact. So significantly, what will happen? The reducing the friction. So similarly, temperature. The elevated temperatures can soften materials, alter microstructures, and change lubrication properties, affecting wear. So next, corrosive media. The chemical reactions with the environment, that is oxidation, corrosion, can accelerate wear by weakening material surfaces. So chemical reactions with the environment, the example oxidation or corrosion, can accelerate the wear by weakening material surfaces, corrosion media, and temperature and lubrication. These are the environment factors. Next, type of motion. So type of motion is sliding wear, rolling wear, and impact wear, and erosion wear. So sliding wear in this occurs when surfaces slide against each other, leading to material transfer or deformation. So in the case of rolling wear, occurs in rolling contacts such as in bearings, where cyclic stress can lead to surface fatigue. Similarly, impact wear results from repeated impacts causing surface fatigue or fracture. Already I have studied in fatigue phenomena. So results from repeated loads. The subjected to the component subjected to repeated loads, repeated impacts causing surface failure. So that is impact wear. Rolling wear already occurs in rolling contacts like rolling contact bearings, where cyclic stress can lead to surface fatigue, and erosive wear caused by the impact of solid particles or liquid droplets on a surface, leading to material removal. This type of wear is erosive wear. This will be caused by the due to the impact of solid particles only. Next types of wear: adhesive wear, abrasive wear. The adhesive wear is occurs when two surfaces slide over each other, causing material transfer due to adhesive forces at the contact points. So this type of wear is generally in metal on metal contacts without adequate lubrication. So the abrasive wear happens when hard particles or asperities slide or roll against a surface, cutting or flowing material away. Can be two body hard asperities directly contacting the surface, or three body hard particles trapped between two surfaces. Next, corrosive wear involves chemical or electrochemical reactions between the surface and the environment, leading to material degradation. So this type of wear often seen in harsh environments, such as in chemical plants or marine applications. Fatigue wear. So results from repeated cyclic stresses. We have seen in the previous slide, causing cracks and material removal over time. Common in rolling elements like bearings and gears. Next, erosive wear caused by the impact of solid or liquid particles on a surface, leading to material loss. The common in fluid handling equipment like pumps and turbines. Fretting wear occurs due to small amplitude oscillatory motion between contacting surfaces, often leading to surface damage and material removal. This type of fretting wear you can see in joints and connections subjected to vibrations. Joints and connections wherever present the joints or connection is subjected to vibrations. In this case, you can see the fretting wear. Importance of understanding wear. So design and maintenance. Knowledge of wear mechanisms and governing parameters is crucial for designing components with high durability and for developing maintenance strategies. The material selection, selecting appropriate materials and surface treatments based on wear resistance can enhance the performance and the lifespan of components. Next, lubrication. Effective lubrication strategies can mitigate wear and extend the operational life of mechanical systems. The cost efficiency, reducing wear related failures, can lower maintenance cost and downtime, improving overall system efficiency and reliability. So that you can reduce the if you reduce the wear related failures, uh, you can reduce the downtime and improve the overall system. Next question is right short notes on operating wear and percussion wear. In the case of operating wear, occurs due to small amplitude oscillatory motion between two contact surfaces. This type of wear often arises in mechanical joints where there is a slight relative motion between surfaces and under load. So already we have studied in the theory part. So now we will see percussion wear. In this, actually this operating wear mechanism shown here, the repetitive small movements cause surface degradation. This leads to the formation of wear particles and potential oxidation. So this type of wear is common in bolted joints and spline shafts and electrical connectors. So how to prevent this type of wear? Use of lubricants to reduce friction, application of surface coatings or treatments, designing for better fit and reducing relative motion. So percussion wear description is percussion wear occurs due to repetitive impact or hammering actions on a material. So this is the cyclic load leading to deformation, material displacement, and eventual wear. The mechanism is repeated impact causes surface deformation. So material may crack and spall off due to the constant hammering. So this type of wear is commonly occurred in hammering and anvils in machinery subjected to repetitive striking actions. Next question is describe the various surface coating methods. So surface treatments are processes applied to the surface of a material to improve its properties such as hardness, wear resistance, corrosive resistance, and aesthetics. And these treatments can be physical or chemical or mechanical in nature. So all these surface coatings methods leads to prevent the wear, and then you can improve the performance and increase the lifespan of the product. The coatings are electroplating coating and anodizing and power coating and PVD, the physical vapor deposition. I have studied in a theory for what is this electroplating and then anodizing and power coating. Physical vapor deposition also you know. Examples include in titanium nitride and chromium nitride coatings. Next, heat treatment methods. So carburizing methods and nitriding method and induction hardening. So this to increase the surface hardness. So by using the heat treatment properties, you can enhance the properties of the material. So mechanical treatment, short painting method and laser surface treatment. So by using these methods, you can improve the hardening or creating patterns and improve the fatigue resistance. Chemical treatment, passivation, phosphating and etching. So using chemicals to selectively remove material from the surface, often used for cleaning or creating patterns. So similarly, in the case of passivation, enhancing the corrosion resistance. So by using phosphating, you can improve the paint adhesion. So thermal spraying, plasma spraying, and HVOF, high velocity oxygen fuel. So common materials include in this spraying ceramics and metals. So ion implementation, and then electroless plating. So ion implementation, electroless plating already have studied. So by using this electroless plating, resulting in a uniform coating. So you can improve the hardness and wear resistance. So electroless plating commonly in nickel coating onto a surface without using an electric current. So next one is the list out the international standards used in wear measurement. Various standards are there like ASTM International Standard and ISO International Organization for Standardization and DIN standards are there. So all these standards for wear measurements, they provide guidelines and procedures to ensure the consistency and reliable testing of materials for wear resistance. Those standards are ASTM standards, ASTM G999 and 65 and G133 and D3702. These are the standards comes under the ASTM standards. And ISO standards. The ISO standards are ISO 20808 and ISO 71482 and ISO 8251. All these standards specify the test method for the determination of the wear resistance of the ceramics using a reciprocating sliding method. Similarly, the 71482, the standard provides method for testing the tribological properties of plain bearings, the focusing on dry and lubricated conditions. Similarly, the ISO 8251. The standard covers the method for evaluating the wear resistance of coatings by the taper abrasion method. So it involves rotating abrasive wheel against the coating. DIN standards. DIN standards are 50320. The standard describes the pin on disc wear testing method. Already we have studied about this experiment, pin on disc. By using this pin on disc wear testing, we can calculate the wear rate of the particular material. Similarly, the friction also you can calculate, you can evaluate. So this standard describes similar to the method, similar to the ASTM G99, focusing on the measurement of friction and wear. So DIN 51834. The standard outline the procedures for testing lubricating greases using a 4-ball tester to evaluate wear and extreme pressure properties. For calculating the wear and extreme pressure properties, the standards will use. Other standards are there. There are ISO 12947, ISO 17025. These commonly used for textiles to determine their resistance to wear. So this type of ISO 17025 not specific to wear testing, but specify general requirements for the competence of testing and calibration laboratories, ensuring reliable and accurate measurement results. So these are the references I have taken for this model question paper answers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.